2013, problem 3. Hot water dripping through a coffee maker, filling a large cup. The amount of coffee in the cup at time t is given by a differentiable function c, where t is measured in minutes. Selected values of c in ounces are given in the table. I think it's important to get oriented with c. Most of this course is about f, f prime, and f double prime, basically. And if you had to pick, you certainly would call c an example of f. It's an amount, it's not a rate, and that's how you get this problem started. If you don't get on the right foot, the problem tends to fall apart. So get yourself started the right way. Part A, use the data in the table to approximate c prime of 3.5. Show computations that lead to your answer and indicate units. C prime would be the derivative of c, and you don't have c, you just have values of c. So that means you're going to find some kind of a slope, and that will at least approximate the instantaneous rate of change of c at 3.5. So 3 to 4, 3.5 is right in the middle, and away we go. I certainly don't need to simplify this, but I do need to indicate units of measure, and we're given ounces and then minutes, so it would be ounces per minute. Part B, is there a time t on the interval 2 to 4 closed interval at which c prime of t is equal to 2? Justify your answer. This is going to be a mean value theorem question, guaranteed. The reason being, again, you have only values of c to work with. You don't have values of c prime, and you don't have c or c prime. So since they're asking if c prime has to equal 2 on this interval, you're going to calculate the average rate of change, and I'm betting it's going to be 2. That was magical. So since the average rate of change on this closed interval is 2, the mean value theorem will be involved. Let's take a look, though, and be very careful. We are told that c is differentiable, okay, and that's just all together on the interval 0 to 6. Remember that differentiability implies continuity, and if you want to get really technical, you need continuity on the closed interval and differentiability on the open interval in question, and we have both. Part C, use a midpoint sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of that. First of all, this is the average value formula. You should recognize that. If you don't like 1/6, think of it as 1 over 6 minus 0. Then we're supposed to use correct units and explain the meaning of it, so it's going to be an average value of some sort. So the midpoint sum, I think, is, since there are 3 subintervals of equal length, if you look, you have 6 units to get that job done. So 1, 2, and 3. Really good way to draw this is like this. You can see that the intervals overlap to some degree, but if you just concentrate on the t values, you can't go wrong, because they're obviously 2 units wide each. Couple of things to note. Don't forget to bring that 1/6 forward. That's a very common mistake. I used to do that all the time. The other thing to note is that we're using the middle y values. So in case you don't know how a midpoint Riemann sum goes, you have 3 y values to choose from, and for the midpoint Riemann sum you choose the one in the middle. If you had to pick LRAM for this question, you'd be choosing the 0 that you see. If you had to pick RRAM, you'd be choosing the 8.8. As for the meaning, since it is an average value formula question, you have to remember that whatever function you put into the average value formula is the function whose average value you are finding. And C gives the number of ounces of hot water, sorry, in the cup. Let's see, amount of coffee in the cup, sorry. So it's the number of ounces of coffee. So this will be the average number of ounces. It's very important to note that when you're told to give units of measure, you have to include the word ounces and the word minutes. The minutes especially seems picky, but just get used to it. That's what's required. Part D. The amount of coffee in the cup in ounces is modeled by B. Stuff. Using this model, find the rate at which the amount of coffee in the cup is changing when t equals 5. So the rate would be the derivative. B is an amount, so it's kind of like C, and therefore I just do a derivative and plug in 5. Chain rule. Sorry, this is a little messy, but just plug in 5, don't make any attempt to simplify, and we're all done.